And when you have the right timings for the nonces, you can predict which nonces are coming. And if you can do that, you can even speed up your attack. So actually, that is what it's doing now. It's trying to see which values and which nonces are used most. Oh, and then it says, oh, okay, well, this nonce is used the most times. It's going to use that one to attack. And thereby you can look to the screen and actually recovering the keys from the card. And if you look at it this way, then you actually see that it is so easy to break the card. And that's not really what it was meant to be. So, yeah. And you can do this with a very cheap reader. $30, and you can communicate it to it, and you can send just the right values, and it's just giving you, almost shouting the keys to you. So, yeah, I'll say, yeah, I don't have to say anything about it. It's showing itself, I guess. So, well, let's get back to the presentation. I showed this. You can do it even. This can all be done in 1 second on a Proxmark because you can control the timing a little bit better. So you can even predict the nonces at the perfect way. So yeah, that's convenient. But okay, take a minute on this reader I showed, which well, if you want to play with it, toy with it, or even buy it, I have a box with me. So there is. Well, let's get back to that slide of the security we had. Because if we look at the multi-authentication, that's actually not really a very hard authentication. In the authentication, I did not really go into that, but I can tell you all about it. It is like a random number, and it's reusing that random number, but you can predict the answers from the first random that is sent. So you can actually stripe them out of the authentication, and then you have 64 bits of key stream. So the authentication leaks already the key, because you only need 50 bits to get the key. 50 bits is enough, and you have like 64 bits of key stream. So in one authentication, you know already what the key was. Then the random number challenges. I mean, we've seen it. It is not really a random number if you only have 65,000 possibilities. The proprietary non-public algorithm is quite public now. The guys from Germany did a very nice job to give a head start, and I guess we finished it, and it's pretty out of the blue there, so everybody can learn what's actually on with this card, and maybe does not make a mistake in the future. Well, the encrypted communication is not really encrypted if you can, of course, know the key already at the end of the authentication, where you already know the key. Well, then the rest is not encrypted because you can decrypt it on the fly. The obfuscated parity information, well, that's not really a security measure, right? I mean, it's now known how they do it, so you can actually do it yourself. And then we have like a hardware implementation, but that was like maybe 2 years ago, but last year there was a software implementation, and maybe next year there is even a JavaScript implementation, I don't know. But and then the last one, which I said like, oh, let's say, send only one message in the plane and the rest will be encrypted. Well, when they're using that one, they even make a bigger mistake because they're giving away the key, almost, what they showed with the card here. So, getting back to that fixed unique identifier, that's the only thing that's left. Since there are like 5 different Mifare clones already available in China, Russia, and I guess different countries which I cannot really translate in Google Translate yet, but then there probably will be next year a card where you can set your own UID, and then you have like a very mixed up card where you can do everything with. Well, what's the conclusion? The Mifare Classic actually just broken beyond repair. You've seen this. You can actually see like every attack you can do on a cheap reader. In a few years you can run it on your mobile phone and send it over. And we all remember that security by obscurity is not really the way to work through. I mean, you all know it from the DVD, the Bluetooth, and the keylog thingies, which is the core security stuff. Well, then it's maybe nice to hide your failure if you just don't tell how it works. But that's a question maybe. We do not know, of course, if that is what you want to say there. Well, there is so much NDAs in this chip business and in that RFID business. It's hard to get by documentation. So it's I've started an open source community for a library for this white reader and for this Proxmark, and just trying to get it more in the open, more more actually open discussion about what the security on that RFID field is and what is actually in the field used, because can be trusted. Now, you can come by if you have any questions offline. Let's say there are some readers where you can play with what I said, and it's on the end of the camping Z, so I guess on the end of HAR. It's the farthest away camping site, but there was space for us out there. On the internet, you can find us on these websites. Yeah, there is nice information if you want to learn more about it. Thank you all.
Do we have questions? Must be many. Here's one.
Okay, so I have two questions. The first one, that attack you showed us, it was offline attack. I mean, do you need to sniff communication between RFID reader, official reader with the key and card, or it's pure offline attack? I mean,
sorry.
My question is, you shown us one practical attack.
Yeah.
And this attack was offline. I mean, do you need a reader with some key or not?
No. This is a card-only attack. But that doesn't mean you only need a card, and you need, of course, a reader. But you put the reader down, you lay the card on top of it, you run your tool, and it gets the keys out of it.
Yeah, because as I know, home I did one practical attack. I used Proxmark to sniff communication between reader and card, and there is a Crypto1 implementation. Do you know?
Yes.
Yeah. So this is a different kind of attack you've shown us.
This is
different one. I mean,
preferred.
Different.
Oh, this is different. Oh, actually, no. This is in crypto. There are some implementation. I didn't really look in the latest version, but the guy who wrote this, that software actually implemented the attacks which are written in the scientific papers. And this one we published in May in Oakland in the Security and Privacy Conference. So it is implemented in crypto, I guess. I didn't really look at it, the implementation. But it's not really different from it, but it's a different implementation because it was our own test values, I guess.
Hello. So the attack you showed just then relied on block 0 having a default key, and then you were rolling back the keys for the remaining blocks. Does the attack still work if you don't know the key for the first block?
No, that will not work if you do not know the key of a block, not the first block.